Now we begin with the part 1, the multiple choice question part of the exam scheme. Please note, I will do the direct and shortcut methods to solve this part because it is in the multiple choice question format. If you want the detailed explanations, please go to the lesson explanations in the playlist. The question 1 is to find critical numbers of a given function. The method to solve critical number is just the same. You need to derive the given function and make the derived part equal to 0 and solve it. That's it. Now I will show you in a minute, but before that, here they have told to find what does that represent, whether the critical number represents local maximum or minimum or neither. So in order to do this, we have different methods. If it is x to the power 2, I will tell you the double derivative method is the easiest. But if it is more than x power 2, then I will show you another method in the next problem. So now, just derive this f dash of x. What happens here? It will be minus 2x plus 4. Now make this part equal to 0 and solve it. Minus 2x plus 4. You can take minus 2x to the other side. It becomes plus 2x equals 4. X is equal to 2. We have found the critical number. This is the critical number. But we don't know whether it's the maximum point or minimum point or what does it represent. Now, in order to solve this, for this particular problem, it's a parabola, right? If you know the graph of parabola, you can tell minus x squared is opening downwards, it will have a maximum point. You can directly do that as well. Otherwise, so that is the easiest of all. Say plus x squared will open upwards. So this should have minimum point. This should have maximum point. That's the easiest of all the methods. But otherwise, you can just do double derivative. Double derive this. F dash of x is already there. Double derive it. You're going to get minus 2. If this is minus 2, that means it's less than 0. Whenever double derivative is less than 0, it will open up downward. I mean, it's concaving downwards. That means it has a maximum point. So this is maximum. In your options, you will have x is equal to maximum, x is equal to minimum. So you need to choose x is equal to maximum point. That's how we solve it. Here we have minimum point because it's positive. It will open up upwards. And this is the critical number, minimum. Here x is equal to 2, maximum. Now let's do this problem here. Now, for these methods, these problems and higher powers, please follow the method which I teach you now. Just derive it and find the critical numbers first. It will be minus 3x squared plus 6x. Make this equal to 0. You'll have minus 3x squared plus 6x equals 0. We can use the calculator to solve quadratics easily. You need to go to mode 5 and 3. Put in the coefficients of x squared first. It's minus 3. Then for x, it's... Now, I have written this wrong. It's not 6. I just realized it over here. This is x squared. 2 comes down, multiplies with 6. It becomes 12. So the coefficient of x is 12. And then there is no constant term at 0. So the answer is 4 and 0. We have the critical numbers of x is equal to 4 and 0. Now, how do you know which is maximum, which is minimum? This is not closely bound or anything. So these are the only critical points. So what you need to do is this given function, not the derived one, the given function, original equation, just substitute this as f of 4 and then you can substitute as f of 0. After that, f of 0. And then solve it up. So how would you do it? Since you have two numbers, instead of putting 4, replacing x as 4 and then 0, it will take time. The easier method is go to computation mode, type this equation minus alpha x cube, then we have plus 6 alpha x squared and plus 2. Now, don't press equal to, you won't get anything. Press calc and put in the value of 4. What is this? It's 34. Remember this. You can write it out over here. And then calc at 0. It'll be the constant term. That's 2. So here we got 34 and here we got 2. Now which is maximum? 4. This is maximum point and 0 is minimum point. So from this method we can easily tell which is maximum and minimum. You can see x is equal to 4 is local maximum because it has a higher value, whereas 0 had a minimum value. You can try these problems by yourselves. I will do, this was just done, cubic. I'll do one more type. If it is powerful, I'll just do this one over here. The first problem, just derive this first quickly. It'll be 4x cubed minus 4x, and that becomes 0. Now equate it to 0, 4x cubed minus 4x. You can directly factor it and solve for x as well, but I'll just use calculator, which is more easier. Here we need to go to more phi, and 2 doesn't work because it's cubic. So go to more phi 4. And now type in the coefficient of x cubed is 4. There is no x square term, so it's 0, and then x is minus 4, and then we have 0 again. The answer is 1, minus 1, and 0. We have three numbers now, three critical numbers. 1, minus 1, 0. We need to substitute f of 1, f of minus 1, and f of 0 and find which is maximum, which is minimum, and which is neither. So what you need to do is type this equation over here in terms of x. That is alpha x, and type it out over here. And then you need to press calc and start checking for these values. I will start with 1. It is 0 if I have 1. Now let me start with calc minus 1. Again it is 0. So now these both values, I got 0 and 0. So they are equal. If they are maximum, both are maximum. If they are minimum, both are minimum. And let's check for calc of 0, and it's 1. So this is the maximum point, and these both are minimum points. That is how we can easily solve it up. You can see here plus and minus 1 and 0 are critical numbers. The plus and minus 1 were minimum. Why? Because the value was 0, whereas x is equal to 0 is maximum, local maximum, because we got 1 as the answer. Same way you can solve it up. That's the end of this topic. If you have any doubts, any questions, please post them in the comments. The question 2 is to find absolute extrema of a given function. If you're thorough with the question 1, especially the functions with x to the power 3 or higher, it's the same method what we will do now. Here we need to find the maximum or the minimum points. They occur at critical numbers. So first we need to find the critical numbers of a function, that is f dash of x. Here we will have 3x squared minus 3, that's it. Now f dash of x becomes 0, it will be 3x squared minus 3. Now we put in the calculator. After going to mod phi 3, you have to put in the coefficients. Coefficient of x squared is 3. There is no coefficient of x, so it's 0. And last, the constant term is minus 3. The answers are x is 1 and minus 1. So the critical number is x is equal to 1 and x is equal to minus 1. Now here, we need to solve for the absolute extrema and minima. It's only possible when it's a closed interval, because now here we are just dealing with this interval. Here now, in a closed limit, the critical numbers will not just be the x values, even the limits intervals over here as well. So the critical numbers x will be 1, which falls inside this interval, 0 and 2. So we need to find f of 1, f of 0 and f of 2 and find which is maximum, minimum. The maximum would be the absolute max and minimum would be the absolute minimum. Let's take our calculators and find the max and minimum points. All you need to do is type in this equation and then calculate all these values. Calculating 1, you will get minus 1 as the value. At 0 we get 1, and lastly at 2 we get 3. So this was minus 1, 1 and 3. This is absolute minimum, and over here we get maximum. Same thing can be tried over here in the next interval. It's just that the critical numbers at Cn, critical numbers would be -3, 2, 1, -1, because -1 also falls in this interval. So you will have to do f of these three, sorry, over here there is no 0. You have to do f of 1, f of -1, f of 3, -3, and f of 2. So these are the four functions you need to do. Here all you need to do is calc at f of 1. It is -1, calc at -1. We get 3. I'll just write it out over here. We get -1, 3, and calc of -3 is -17, and lastly calculating at 2 we get 3. So here we got -17 and over here we got 3. So the maximum points are 2 points. 3 and 3 both are maximum, so this and this would be absolute maximum, and the absolute minimum is at f of -3. So this is how we basically solve these problems. You can see over here we had got absolute minimum. I've just written minimum, but they have clearly mentioned absolute minimum. That was at, which was the value we got? F of 1. Yes, f of 1 is absolute minimum, and f of 2 is equal to 3 is absolute max. Same over here, we got 2 absolute max and 1 absolute minimum. You can do the other problems by yourselves. The method is just the same. Each step is worked out over here. And here I will quickly tell you one important thing. We can just derive it by using power rule, but here you get it in terms of denominator. Now, here you don't make it equal to 0. Why? Because this is undefined, right? If you make x is 0. But critical numbers are not only when derivative is equal to 0, also the undefined numbers. So this is undefined point, and that is also a critical number. So x equals 0 is a critical number. And then for the first one, we have to take these two intervals. But does 0 fall within this? No. So we just take -4 and -2 for the part A. See, it's only -4 and -2. Why? Because 0 doesn't belong here, right? Since it's not writing, you don't need to write all that. Just derive it. You will understand critical number is 0. Leave that. Just substitute -4 over here instead of x and put -2 instead of x and get the values. See which is maximum, which is minimum. Same thing here, but here the 0 is within this interval, so all three values you need to substitute and solve. So you'll get it. And over here, you will get 0. When you put over here, you'll get 0. -1 will be 1. And over here, you get more than 3. When you put 3, it'll be 3 to the power 2 by thirds. So which is the maximum? Obviously, 3 to the power 2 by 3. And minimum would be 0. So that's how we solve it. Okay, I will do this one. It's about sine x and cos x. So first is derivation, f dash of x. What is the derivation of sine x? It is positive cos x, but cos x derivation is minus sine x. Now make this equal to 0, cos x minus sine x. Now I will take this to the other side. Sine x is equal to cos x. When is sine x and cos x equal? If you remember the unit circle, or if you know the values of sine and cos, they are equal at 45 degrees, right? That is pi by 4. So that is the answer. X is equal to pi by 4, because pi by 4. Now since they have given in intervals in the limit, and then we can easily, this will be included in the limit over here, and it's not included over here. So that's how we solve it. But how do you do it in the calculator? I'll show you now. First thing, clear your calculator here. Now, I always tell use radian mode when you're solving sine and cos, but here don't go to use radian mode, because if you use radian, you're not going to get in terms of pi. It'll be like 0.55, something like that. I will show you now. Sine x, right? Alpha x, just equate it to cos x. See, now I'll press shift and solve. Okay, now it's in degree mode, so I got the answer directly, but I'll change it to radian mode. 4. Now I will shift and solve. Now, see, the thing is, once I get an answer, you will get an error. So now clear the calculator. Please do clear your calculator when you're using trigonometric equations. Now I should get the correct answer. See, sine x equals cos alpha x. But first I will change this to radian mode, shift mode 4. Now I'll press shift and solve and equal to. The answer is 0.785. You might be wondering what is this? But this is actually pi by 4. Look here. If I solve pi by 4, I'm getting this answer. It is 0.785. So the problem is if you get 0.785, you won't know what exactly it is, right? So I'll quickly clear the calculator. Keep it in degrees. Solve sine x equals cos x. Shift and solve. Here, whatever the answer you get will be in degrees. That's fine, 45. Now just divide this by 180. You will convert to radian mode. Now this is, you have to multiply pi over here. So 1 by 4 pi or pi by 4 is in terms of radians. Or it's very easy to know. Pi by 2 is 90 degree. Pi means 180 degree. So 45 would be pi by 4. That's how we can understand. And now 1/4 pi falls within this range. So we have to use here the critical numbers 0, 2 pi and pi by 4 and solve for maximum minimum. But in the second case, look, it's pi by 2, 2 pi. We don't use this pi by 4. Critical number is not in this range. Now, to find the absolute maximum or minimum, you need to put the critical numbers in this equation, isn't it? But remember, change the mode to radian. And now calculate at any value you want. 0, you'll get the answer 1. Now calculate it at 2 pi, you'll get the correct answer. It's 1 again. So you can see f of 0 was 1, f of 2 pi was 1. What about pi by 4? Calculate pi by 4. Just press shift and this symbol pi divided by 4. The answer is root 2 or 1.41. So this is how we solve it up. So please make sure when you're checking the absolute maximum minimum, put this original equation, make it in the radian mode and then solve it up. That's how we can do it. The worked out solution is available here. See, all the problems are straightforward. Now here when you derive it, please remember sometimes you have to do chain rule, sometimes you might have to do product rule or quotient rule, and then just the same method. It's an easy problem. Here we are using product rule of derivation. So please look over here. That is u dash v plus uv dash, and then you can solve it. And here we are using quotient rule because you can't just simplify this further. You need to use the quotient rule and solve it out. So this is tan inverse x. What is the formula of tan inverse x? It's 1 by 1 plus x squared. Use the formula and then solve it out. Again, these are all straightforward. Once you derive it, make it equal to 0. You can just put this entirely in the calculator, you'll get the answer. Or here it is very simple. If you take this to the other side, everything becomes 0. 2x is equal to 0. X is 0. So this is simple, but otherwise you can just put this in calculator. If your calculator is not giving you correct answer, please clear it out and then try solving it. Here also it's again straightforward problems, just that you have to use quotient rule, and here as well quotient rule, and then solve it out. That's the end of this topic. Please try and solve more problems by yourselves, and any doubts or any difficulties, please post them in the comments. The third question is to identify increasing and decreasing functions. Here we can use the methods which we have learned before, but the second derivative test is the easiest of all the methods in this case. I'll tell you why. We can do the previous methods, but we won't get the complete understanding. Now, if they just asked you to sketch a graph, it's a different case, which I'll tell you in a while. But now let's try to find increasing and decreasing. First, we need critical numbers. Derive this. Y is f of x itself. I'll just write y dash, derivation of that, is 3x squared minus 3. Now make this equal to 0. It will be 3x squared minus 3. You can put in the calculator and solve for the critical numbers. I've put in the coefficients in mode phi 3. It's 3. There is no coefficient of x, so it's 0 and then minus 3. The critical numbers are 1 and minus 1. So here we get x is equal to 1 and minus 1. There is no closed intervals here. So what do? We consider these as the critical numbers and solve. Now, if you're going to put this back in this equation, you're going to get the absolute maximum and minimum point, but not exactly where is it increasing or decreasing. Now, imagine you get the points, say, like this. Okay, I'm just doing it random. I don't know what's the answers over here. Now, you get from year to year, it will increase, okay, because this is low, this is high. But what about the left of this? Is it going up? Is it going down? What's happening? I have no much information, right? Now, there are plenty methods you can get more accurate information, but the basic information can be found from double derivative method. What is that? Just derive this equation again, double derive it. That will be 6x, that's it. Now you need to substitute both the critical numbers at this. At x is equal to 1, at x is equal to minus 1. Here, when x is equal to 1, it'll be 6 times 1, that is positive 6, which is greater than 0. But when it's minus 1, it'll be 6 times minus 1 minus 6, which is less than 0. Now here, 6 greater than 0, what does this mean? Double derivative is greater than 0. The graph is opening upwards. Positive, whenever it's a positive number in double derivative, it opens upwards. In when it's negative number, it opened downwards like this. So it's going to be a minimum point in the first case, a maximum point in the second case. Now this will help us a lot. Now the critical numbers are minus 1 and 1, right? What is happening? I have x is equal to 1 minimum point. So I will just put it below the graph. It's not accurate, just a random point. And what about this? At minus 1, I'm going to have a maximum point. I know so much. And I know how the graph is as well, isn't it? So at minus 1, it's something like this. And at plus 1, it's something like this. So where is it increasing? It's increasing here, decreasing here, increasing here. So this is very useful information we have over here. So I can tell from minus infinity till minus 1, and where is this? From 1 till infinity, and from 1 till infinity, it's increasing. Increasing will be given in a technical term that is greater than 0, okay? Where is it decreasing? From minus 1 to 1, positive 1, it is decreasing. So this is it. Or it's less than 0, negative. So this is how we can do it, because the other methods, you can do the number line method as well. You can do it. We have done it in the writing part 2. So it's up to you to choose this. Now here, when you're doing second derivative, you just have to derive it again, because when you derive it once, it becomes easier. And then when you derive it again, it becomes, comparatively easier to derive. And then just substitute the critical numbers, see what are the functions. You don't need to find this, because they did not ask you that. They did not ask absolute maximum minimum. They just asked you to find increasing, decreasing, right? That's it. So here you can see y is increasing. Where is it increasing? From 1 to infinity and minus infinity to minus 1. And where is it decreasing? So here they have told the technical term less than 0 means it's decreasing at minus 1 to 1. So that's the answers. Now, what if the graphs are given? If the graphs are given, it's so easy to find it out. Whatever is the given equation, you need to put in the calculator. Now here we have put this equation in this calculator, and then calculate at any point. I'll start with 0. Is 0 nearly 2? Yes, this is 20. So each one is 1, 2, 3, 4, 5. 4, half of 4 is 2. Yes. You can check another point. Let's check minus 2. Calculate at minus 2, it's 0. It must match at all the points. This is how we can easily eliminate the other points. See, now if you just take randomly 2, calculate at 2, it's 4. Yes, it's 4, right? Now, other graphs will not have 4. They will have different values. At x is equal to 2, it will be something else. So you can easily eliminate that and select the correct graph. But you might get the increasing and decreasing part. So we need to do what I did just a while ago. Please do follow the same method, double derivative test, and you can solve it easily. If it's graphing, just put the equation in the calculator and find the correct graph. Solve these problems by yourselves, guys. Yeah, all the worked out solution is there. If you want this presentation, please click on the link and you will be directed over there. Now here it is just fraction power. Use the power rule, solve it up. Now here this is undefined point. Now x is -1. This is the critical number. So the easier method over here to check is the number line method. Let's take the critical number as -1, take a test value of -2 and 0. Now substitute 0 over here, what's going to happen? It's going to be cube root of 1, so it's going to be positive. We do want the value, we just want positive or negative. This means it's increasing here. Now, what's happening before -1? If we take -2, just this is 2 and 3 constant, it's going to be 2 by 3. But what is happening here? Cube root of -2 plus 1, that is cube root of -1. That's -1 itself, right? Now remember, this is cube root, it's not undefined. If it was square of negative numbers, it will be undefined. But now why we have written undefined? Because it's in the denominator. That's a altogether different thing. But here you just put in the calculator, put this equation in the calculator and check for -2. You'll get a negative answer. Why? Because it'll be cube root of -1. It's minus over here. And that means it's decreasing, increasing. So you have minimum point at -1, and the decreasing functions are from -infinity till -1, and from -1 till positive infinity it's increasing. So the graph will be like that. We will just check the graph now. So this is the graph. If you graph it out, there's another method. Since you have been given the equation, we can directly get the graph. I will show you how. If you just click on mode 7, you get the table option. Type this equation here. Alpha x minus 1, close the bracket, to the power 1 divided by 3. Press equal to. If your calculator is the latest model, you'll get this option. You don't have to press anything for this, just press equal to. Some of the calculators, after you type this equation, you'll directly reach here. Now, what you need to do is you need to just give a random range. You can do one thing, find the critical number and then give some values. Otherwise, I would just give -5, start at -5 to say +5. Okay, let's give step of 1. Now here, look at the values. What's happening? See, at -5 it is -1.8, and then it's -1.7. It's decreasing, and 0. Now it's increasing. Can you see there's a change in increase? So from this, you can easily look into the options and eliminate as well. Now, if you're good at this to analyze these functions, then this is a very simple method. It has decreased till 0, but after 0, from 1, can you see that 1? It increased. So this is the thing. Now here we can see there is vertical, so there is no, it's not a critical point, but it's flat line over here at 1. So you can see that's the thing. Same way, you can try any equation. You can do it by yourselves and then directly look at the graph. And you can easily tell where it's increasing, decreasing. Now, since it's sine, it's repetitive. It keeps on increasing, decreasing. And you can easily find it in the graph where it's going up, down, up, down. Same way, you can graph the other problems by yourselves. Try the table method, whichever method, because all the options will be given. You can try any method and get the answers. Same way over here, the detailed explanation is also available. And this is the last one. So if you have any doubts, please post them in the comments and I will see you in the next video. Question 4 is to find local extrema using first derivative test. Now we have done this plenty of times in the previous questions. All the 3 questions, in fact, we have come across this topic. So you can just do that. I will just quickly tell you how. It is just deriving this, derive it out over here. It will be 4x cubed plus 12x squared here. And then that's 0. So what you can do is you can put this as mod phi 4 and put this and you will get the critical numbers. You can do the number line method. That is the first derivative test. depending on number of critical numbers you have. If you have three critical numbers, you find what is happening. If it's plus minus, that means it's increasing, decreasing, increasing, decreasing. This is how we do it. But I'll try to tell you shortcut method. Now that is absolutely actual method. Now since you will have the options with you, let's take out our calculators. Let's press mode 7, that's the table, and type this equation out. Alpha x to the power 4 plus 4 alpha x cube minus 2. Now press equal to. If you get this, just ignore it and press equal to, or if you directly get this, now start at say number 5. Now, this start and stop end number will be highly influenced by the options you have. You will have four options. Now, let me just show you the answer. Here you will have something like this: minus 3 comma 0, 0 comma infinity, like this. Or it'll be minus 5, minus 2, 1, 1, 3, something like that, right? Based on that, try to cover all those numbers. What I would do is I will start with the least number, that is minus 5 here, because minus 5 is lesser than minus 3. And then I will end it at 5. And step, I will just give it 1. And now look over here, something's happening. So at minus 5, it's a huge number. And then minus 4, it's decreasing. It has decreased to minus 2. Again, it's decreasing at minus 3. But then at minus 2, it has increased. So from this table of values, what do I know? It was decreasing and then it starts increasing at minus 3. So that is the important value for me, minus 3. Then what's happening? It's increasing, 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 increasing considerably. See, it's just keep on increasing. So what do I understand over here? I can see that only at minus 3 it starts decrease and then it just kept on increasing. And over here now from the critical numbers, I know there is a critical number at 0 as well. One important thing, you need to find the critical numbers, guys. Derive it, find the critical number. You will get two critical numbers, right? It's very helpful. Even without that, you can use this. You can easily eliminate the other answers. So now from this, I know it goes down at minus 3 and it starts increasing only. So now let's look at this. It's decreasing where? Where is it decreasing? This minus decreasing. Only from minus infinity, that's somewhere minus infinity, till minus 3, it's decreasing. Then from minus 3 till infinity, it just keeps on increasing. Yes, this is what they're telling us. Absolutely true. So there's a minimum point at minus 3 only. From this table, we can easily show that. Let's do one more over here. So what we do is we need to go to mode 7. Once you're in the mode, it'll always be there. Otherwise, just click mode 7 and then type this out. Alpha x to the power 5 minus 5 alpha x squared plus 1. And here, this is not there. Just put minus 5 and end it at 5. And let's step will be 1. And let's observe the values. It's huge numbers, negative, negative. Now over here it's increasing. So it was a very small number. It's coming up. It's coming up. It increased, and now after 0 again it's decreased. Okay, decreased and again it increased. So you can see the jump over here. Now if you have the options, you can easily figure out which are the options. Now if the options are over here, you can see they have told 0, there's a change of slope. They have not given the options properly. Generally, you will have options like this. From minus infinity to one number, one more number, increasing, decreasing. Here they have just explained what it is. But anyways, we can see here 0 is also increasing. Till 0 it increased. Can you see? At 0 the slope changes from positive to negative. Yes, because until 0 the numbers were very small, right? Very, very small numbers. It increased till 0. And then it fell down again. Can you see? At 0 to 1, it fell down to minus 3. And then, see, you can see at 1, it decreased. But then again, it started increasing. Now over here we have the critical number cube root of 2. It is about less than 1.5. It's more than 1.1, somewhere over there. So at that point, more than 1 but less than 2, definitely it's less than 1.4, I guess. We can see again it starts increasing. That is at this point. Slope changes from negative to positive. Yes, that is what they have clearly mentioned. Now over here, again it goes up. That is at cube root 2. So this is how we can easily look at the answer and then tell the correct answer. So this is written in sentences, but yes, absolutely makes sense. Let us try this problem as well. It's very simple. Alpha x multiplied by e to the power minus e to the power. So you need to press shift and the symbol over here, minus 2 alpha x. Now, it's very important to start based on the options. Okay, let's look at the options. Over here, you can see there's half. So if I take take a smaller values, generally e to the power x and all will be, smaller numbers. You need to look at the options, all the four options, and then reasonably choose it. What I'll do is I'll choose minus 2 because other options might have been other values, and I'll end it at say 2 itself. And here for these exponentials, take the step half. You'll get much better clarity. If you have say 1/4, then I would take 0.25. But here half is 0.5, so I'll take half. Now you can see here, at negative 2, what's happening? You have a huge value. Then it's increasing because minus big numbers are small, right? So it's still increasing, 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 and it became 0. At 0.5, it's increasing. But look here now, at 1, till 0.5, it went up. But at 1, it is going down, 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 and there it is. So yes, maximum point. Why? Because it went up till half and then it fell down, right? So 1/2 is the maximum point. So this is a shortcut method. I hope you find this helpful because you can explore and find different methods as well. Now, since the answers are given to you, four options are given, this is very effective method. So please do try these problems by yourselves. Any method you can try, and even for tan inverse, you can try that, or you can derive it and do whichever method you want. You can start solving it. Especially for trig functions also, you can easily graph it by, you will get the table of graphs. So no problem in that. Try it out and check all these problems by yourselves. The worked out solutions are over here as well. And this is it. Even for this, if you graph it, you can easily understand which is maximum, minimum, and solve it up. That's it for this question. Try exploring the table method. It's a new and an easy method. Only for the MCQ part it will work. Do try it. And if you have any doubts, please post them in the comments and I will get back to you very soon. The question 5 is to find the inflection points in the given questions. This can be done by double derivative. Here we have an equation. All you need to do is double derivative. F dash. You should start with single derivative, then you can go to double. This is f prime basically. F prime of x is 3x squared minus 3 times 2 times 3 is 6x plus 4. This will give you the critical numbers, the increasing, decreasing, but we need double derivative. So f double dash of x would give us 6x minus 6. Equate double derivative of 0. Then we get the inflection point. It will be 6x equals positive 6. This 6 becomes minus 6 becomes positive and it goes to the other side. I have written 6x first. X will be 1. This is the inflection point. Now, when the inflection point is just 1, here in such cases, don't go to do a complicated method or anything. It's very easy. This is it. And now you can just do the number line and find it out if you want to find concaving up and down. But if it's just the inflection point, this is it. This is the answer. But here now, 1 is the inflection point. So let me take a value less than 1. If I take a value less than 1, that will be 0. And over here, I'll take more than 1, say 2. Substitute it back in the double derived equation over here. If you put 6 as x as 0, you will get negative 6, so minus. And here if you put 2, it will be 12 minus 6, it's positive 6. plus. It's very easy. Now here it will concave downwards, it will concave upwards. This is the answer. This is it. Please remember, if you just get one inflection point, or if the equation is a simple one, x cube, when we derive it, we will double derive it, we'll just get a linear term. To this, it's very, very simple. But let's look into a complicated problem. That's the answer here. I'll just write it out properly. Inflection point is x is equal to 1. It's concaving downwards from minus infinity till 1 and concaving upwards from 1 till infinity. So that is the answers over here. So you can see the solution. Here f double derivative is greater than 0 at, sorry, this is increasing, decreasing. This one, concaving down, we had got the same, right? Down from minus infinity to 1 and up from 1 to infinity. And this is the inflection point. Now, if you have, say, x to the power 4 or a complicated equation, let's try to do a calculator method as well. But the first thing is you can just double derive it and get the answer. So let me just try it out. F dash of x is equal to 4x cubed minus 12x plus 2. And then when you double derive it over here, it will be 12x squared minus 12. This is it. Now we can put it in the calculator, mod 5, 3 and get the answers. But since 12 and 12 is common, it's going to be x is equal to plus or minus 1 by factoring. These are the inflection points. Now, you can do minus 1 plus 1 and find the points and do it out. The entire lesson explanation is done on this. But now I will suggest you a shortcut method because it's MCQ part. Let's take our calculators. Let's go to mod 7, that gives us the table. Let's type this equation out. Alpha x to the power 4 minus 6 alpha x squared plus 2x plus 3. And now press equal to. If you have your latest model of calculator, then you will get this option. Just ignore it, press equal to. Now the starting point, here we have minus 1, right? Let's take some 2 to 3 values less than minus 1. So what I would suggest is you can start like minus 3 or minus 4. Okay, start from the least value, some values behind it. And ending, 1 is the maximum point. Depending on the options. Now, if your options are say 3, I would suggest to go with 5. Okay, now depending on all the 4 options. Then what you do is you can press, say I will consider over here 4. For the step, if you have 0.5, it will give you more detailed data, in the sense from 4, 3.5, 2.5, all these values data will be given. But if you put step 1, the x values will be from 4, 3, 2, 1, that's it, as a whole. But the problem is if I put minus 0.5, it may not give me the answer, it will tell insufficient data. Okay, here I got it, but sometimes you might get an error answer. So then just put step 1, because there is too many values to calculate when it's 0.5, that's why. Now here, let's look into the values. You don't need to graph it, but if you graph it, you'll get a better understanding. For this one, I'll just graph it. Otherwise, you can just look into this data and understand. So let's just draw a coordinate grid. Here we have started from minus 4, say minus 3, minus 2, minus 1, 0. Same thing, 1, 2, 3, 4. Okay. What is the value here? It's 155, which is a big value somewhere over here. Then it's reducing to 72. We can see it's reducing. Once only it fell down till it's reducing considerably over here. And then if you look at the other values, again it's reduced, now increased. See, it reduced from here, it dropped considerably, and then it was over here. Then what happened? From minus 9, it's increasing, right? If it was lesser than minus 9, it should have been minus 10 or something, but it's coming up here. And if you see the other values, now this is the important point. That's somewhere over there, critical numbers will be there. It's increasing. Can you see it's increasing again? Till 0, it is increasing. So what I can do is from here, I know something's happening, increasing, but again at 0.5, it started decreasing. So here I started decreasing again, and now it's becoming more less. until 2 value. See, again it's decreasing, 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 but now at 2 it starts increasing again. 2.5, it's increasing. So this is the graph from this table. Now from this calculator method you get a brief understanding of how the graph is. So even if you didn't have this inflection points, from here, see, if I just join these points, it's something like this, and it's going up over here, and it's something over here. Now, x to the power 4, yes, this graph corresponds to it. You should know the basic understanding of the graphs. If it is x squared, it's going to be something like this, a parabola. X3, it will be just like this. If it is x4, it's generally a W shape. X5 would be having more distinctions over here. So that is the thing. Now, with that basic knowledge, you can easily predict where is the maximum minimum from this information on the graph. Here is maximum 0, minimum would be at -2, minimum at again +2, I believe. I did not plot the right side properly. But then the inflection point will be somewhere in the middle over here. So this is the minimum, this is the maximum, right? From here until over here, it is concaving upwards. And 1 minus 1 is an inflection point. Then from year to year it will concave downwards. This is also an inflection point. Then over here, from here it's going upwards, concaving up. So we have from minus infinity till -1, and from 1 till infinity concaving upwards, concave up. Whereas from -1 to 1 it is concaving down. This is the understanding of the concavity. Inflection points would be -1 and 1. Now, how would you understand if you have not done this derivative test? You have 4 options. From this graph, you can predict, because the options won't be exactly the same. They won't give you 1, 1.2 or something like that. The options might be, minus infinity till 5. Now, is there 5 over here anywhere? No. Is there 3 over here? No. 2 is the maximum minimum point. That's also no. After 2 you must have, and below 0, right? So its most reasonable answer would be -1. Whichever is closer to -1, that is the answer, if -1 is not given. So that's how we can easily predict the answers. This is another shortcut method. Or you can just go with the traditional method of double deriving, making the number line and finding out. It's up to you to choose. And this particular graphing can be done for every problem, even over here. I'll just show you. You can go to mode 7 and type this out. Alpha x plus 1 divided by alpha x. Sorry, I should go down over here, and now alpha x. And here, see, it's better to have an understanding of the options. So then you can easily start at a really nice point. Now I'll just give -5, and I'll give 5, and I'll give the step. I think so I'll get an error if I put step of 0.5. See, it's not allowing me because it's too many values to compute. So what I'll do is I'll calculate, start at -5, end at -5, I'll do it at 1. This gave me the answer. 1 generally gives you for about 10 values. Now over here, what's happening? The graph is -5.2. It's increasing, increasing, and it got an error. See, over here, it increased, increased, increased. Then, yeah, it's still increasing, but then there's an error. Why? Because if you know the graph, this is undefined. At 0, it's undefined over here. And then what is the next thing? Over here, it is increasing, increasing. Okay, it's going. So I know that from this graph, over here at 0, it is undefined. But here it is something like this, and here it is something like this, right? So where is it? Where is the critical number? The undefined point is the critical number because we got an error at 0. So critical number will be 0, and also point of inflection is also 0 over here. Why? Because over there it is basically undefined, right? Undefined points or points which make it 0. So that's one thing. And one more thing would be concaving. See, concaving up where? From the basic understanding of graph, I can easily tell it's concaving up from 0 to infinity, and from -infinity till 0 it is concaving down. So that's given over here, concaving up and down. We're not solving for increasing and decreasing, but here increasing and decreasing also we got the values. They were increasing from -infinity to 0, right? See, it went up, increased, and then 0 was error. So this is how we can easily predict from this graph. You can easily look into the options. I know 0 must be the critical number or the inflection number. Okay, 0 is there. And till 0, it is going something like this, right? So I can tell this is what's happening. Over here also I can tell this is what's happening. So this is how we can predict the answers if you know the basic understanding of graph. Because it's rational, I know the graph is similar to this. So you can try other graphs as well and easily find it out. And here, please do try them. Even for cosine, sine, you can easily do it by graph. Let's do this one. I've typed this equation in the table. Now it is just sine alpha x minus cos x. Now here I will leave it in degrees. I'm not going to change in radians. Why? Because the starting and the ending point, it's better to understand in degrees. If you know the sine or the cosine graph, what generally happens? Sorry for that line. It's something, imagine it's 0. Sine graph will start at 0. It goes up. Now this will be 90, right? And then we have again 180, 270, 360. It starts repeating. It comes over here at 360 degrees. And generally we will denote these in terms of 0, 45, 135. If you know this basic trigonometry, 45 degree would be generally a jump. So here in this case as well, let's take the jump of 45 degrees. But let's not start at just 0. Let's take something little before as well. I would generally suggest you to take minus 180 till 360. Minus 180 degrees, minus pi that is, until positive 360, and let's jump the step be 45 degrees. So every 45 degrees I'm getting values. Now if you plot this out, see like this only, this is a sine graph, but now this graph we can easily plot it out. If you want, you can just plot the points. Minus 180 is 1, then it's 0, it's decreasing here, you can see it's decreasing, and over here it started increasing at minus 45. So it decreased, some minus 45 is just over here, right? It decreased until negative 1 point something like this, and then it increased at minus 1. Sorry, at 0 it became minus 1. So that means it started increasing over here. Somewhere in the middle of this it increased, and then it went up again. It will go, and obviously something happens like this. We know that's the graph. So if you see, it's increasing, and then it decreased at what point? 180. Okay, I randomly did it. I didn't know this, but it seems that it was increasing until 90, and 180 degrees it started dipping down. So now from this basic understanding, where do you think would be the inflection point? We know over here it is concaving up, right? This part is concaving up. Then it's down. Again, it will repeat because over here this is sine, it keeps on repeating. Now this would be from 180 till 45 in middle of that. It's not 90, it will be somewhere 50s or something like that, right? Here we know it's pi by 4. Pi by 4 is 45 degrees. 45 degrees is reasonable. 45 degrees is the inflection point. Okay, so inflection point is 45. I'll tell you what is this k pi. This keeps on repeating every pi term. It just keeps on repeating. See, again it changes. This is the inflection point over here after pi. Again you can see that from here, again every now and then, every the 180 degrees, it keeps on repeating, right? That's the reason. Now from this graph you can easily predict which is the correct inflection point. 4 options will be given. Choose the correct one because it's closest to 45 degrees. So this is my correct answer. Now let us think about where it's concaving up and down. Now since this is the inflection point, left of this, okay, must be concaving downwards, and right of this must be concaving upwards. We can see from here exactly over here it's concaving downwards. This is the concaving downward part, but I have not done the graphing properly, but I can tell for sure from 45 degrees until this is, I'm not sure over here. Let's just check. Looking at the points, you can easily tell it. See, it's increasing, then it's coming down. Okay, it should be somewhere over here. It's 225, I can say. Okay, it's around 225 because it's at 0. This is concaving down. It keeps on repeating. Now again, after one point over here, this 0 to next 0, again it will be concaving down. You can keep on writing it. So you can see this three dots, right? It keeps on going. You don't need to put, only one is enough. What about concaving upwards? You can go behind as well. So the last point will be 45, and from here, if you just do the difference, or you can see this graphing over here, you can just keep on going by. It's around negative 135. So that is the thing. Over here, they have not used negative, but you can, it's up to you, but they have taken this to this, okay, concaving up from here to here. It's up to you. Now that will be 225 to the next point after 225. Where is it? It'll be about 400 and something like that. So that is the answers. Okay, so concaving up, down, once you get the understanding of graph, but please make sure you draw a better graph, like a proper little accurate. See, there are no many points, you can do a accurate graph, so once you do the accurate graph, make sure you can easily look into this graph and find out where it's inflecting up or down, concaving up and down, or the inflection points. So that's how we can solve all these problems just by graphing. Okay, or you can use the derivative tests and also do this out. Please solve all the problems by yourselves and then go through these answers over here. They're all worked out. I remember this with one of my students. It was much easier to do the table method and find the answers rather than double deriving it, because when you double derive it takes long time. It's just that you'll save a lot of time. That's the most important thing. And then you can easily tell where it's concaving up and down. So that's how we solve this topic. Here, please be careful when you're graphing. See, many of you may do the table but not graph it properly if you're doing the shortcut method. So graph an accurate, not very accurate, but at least an understandable graph, and then you can easily find out the inflection point, concaving, and everything. Now we move to the question 6. This is to determine the concavity of a function. Now here you will be given the graphs. So it is a bit easier because you know how the graph is turning out to be. So you have to just pinpoint from the graph what is the range of the concavity, what are the intervals. Now what I would suggest is don't directly jump to concavity. We know concaving something upwards is this and downwards would be something like this. First thing, see where it is changing its increasing and decreasing points. That is the absolute maximum and minimum points. Here it's coming down, and you can see somewhere over here it changes from decreasing, it becomes increasing function. Then from increasing it becomes decreasing, and same thing here. So these are local maxima or minima. But this is not what they wanted. See, they want concavity and inflection points, right? So from here, generally the concavity will happen somewhere in between. Now I can see this is -1, this is 1, this is 0. Somewhere in between, because see it's all concaving upwards, upwards, upwards. Even over here it's upwards. And there'll be some point here somewhere in the middle, negative 0.5, somewhere over there. It starts concaving downwards. Then over here as well at positive 0.5, it would go upwards. So just by looking at this graph, you can tell what would be the limits. So now what would be the interval? So we can say from negative infinity until negative 0.5 it is concaving up, and again it will concave up from 0.5 till positive infinity it concaves upwards. Where is it concaving downwards? From minus 0.5 to, I should put positive 0.5. This is down. So this is the thing. And the inflection point is close to 0.5. Now we are not taking any accurate measure because it may not be 0.5. It can be 0.35. It's not accurate because from this graph we can infer so much. Now you can see the final answer as well. It's approximation around this. See, the inflection point is around this. That is what they are saying. Now that is what we can infer from this figure. It is not exactly accurate points, but it's close to those points. So now that is what we will approximate and write. And over here we can also tell what is maximum and minimum points. It's approximating towards -1 and 1. So even that is mentioned from the graph. Now you can try this problem by yourself, same like what we just now did. I will solve it up over here. First, let's mark the increasing, decreasing points over here, here. So from, minus infinity, it increases up until 0. And then over here till 2, and then it goes again up. Now, where would be the inflection points? I can see this is concaving down, this is concaving up. Somewhere in the middle, I would consider 1 to be the inflection point, and right side of 1 is concaving up, left is concaving down. And this is what is shown over here. It's concaving 1 from 1 to positive infinity, whereas down from minus infinity to positive 1. Now, what would be the increasing limits? From negative infinity until 0, I can say it's increasing, and then again from 2 until infinity. You can see increasing is over here, decreasing is just from 0 to 2. An inflection point from this graph we can infer to be 1. That's how we can easily solve it up. That's it. Please look into the graph, mark some increasing, decreasing points, that is the local maximum, minimum, and then find out the inflection and concavity. Question 7 is to sketch the graph using the first and second derivative tests. Now there are different ways you can do the first derivative test, second derivative, find the concavity and all that. But I will tell you the easiest of all methods. We need the calculator for this. In your calculator, type this equation as it is. Use alpha x cube minus 3 alpha x squared plus 3x. Now once you have typed this equation, you can just look into the 4 options. Now we know this is the answer, right? The graph is the main thing, what we need to do. So you will have 4 options, 4 different graphs. Just choose any point. Let's take calc at 0. Do calculate at 0. It must be 0 because there are variables. So it's 0. Is it matching? Yes. How about we will try another point, say 2.4. Calculate it at 2.4 and we will check. Here it is showing 3.7. So 2.4 is somewhere over here. It corresponds towards that point. It's not accurate, but if you use a scale and just put it over here, then you will see it's accurate because this is 25. So each one will be about 5 and this is somewhere over here. So yeah, it's less than 4. So this is correct. So same way you can test other points. Here we can see there are 4 different options for this particular graph, right? What you do is first type this equation in the calculator. Once you type this equation in the calculator, calculate at different values. Over here, I can see the 2 graphs are undefined at 0 and over here they are defined at 0. So my starting point would be calculate at 0. And what is the answer I'm getting? It's a math error. It is not defined because it becomes 4 divided by 0. So now I can easily eliminate these 2 graphs. This is wrong. This is wrong. Why? Because this is defined at 0. This is also defined at 0. So my answer is either the option 1 or the option 2 because they are both undefined at 0. Now I will choose another point strategically such that I can easily eliminate one of the option. Now don't just put say minus 6. I mean you can put minus 6, you are getting different answers, but I will choose a point say 1 because I know at 1 the answer is more than 4. What about over here? When I choose 1 it should be 0. So let me calculate at 1. The answer is 5. Can you see? At 1 it is 5. Yes, that's accurate because this is somewhere over here and yes, that is 5. Whereas over here at 1 it must be 0. So the option 2 is wrong. The correct answer is this particular graph. So this is how we can easily solve problems by graphing just by putting it in the calculator. Now you might think, why don't I do mode 7 and do the table? Yes, you can do that as well. You can type the equation over here, but then you need to start, stop, and there is lots of things you need to check. You will get a set of values. You need to try and find which is the correct one. I personally feel when you type the equation directly and do the calc method, you can easily eliminate other options and get the correct one. So it's up to you to choose any method. So you can do the same thing for all the other problems as well. Each and every problem will work by this method because every function can be graphed, and therefore you can easily solve by doing this method. Or you can do the first derivative, second derivative, and then come up with the graph as well. So please try to explore different methods because this is all an MCQ. Try to go with the easiest method. So this is the answers. I'm just going through the answers. You can easily solve it up. Now, to find this presentation, you can just click on the link in the description and download it. So I'll directly jump to the end problems now because all of these problems can be done by the method, the shortcut method, which I just now told you. In the question number 7, there is another different type of topic, which is from 49 to 52. Here, they have given you the asymptotes and then asked you to give a possible graph. Now, if it's a graph, now if we come to the last 4 questions of this particular topic, now if we move to the last 4 questions of this question number 7, we can see that there is a different type of problem. We need to write a possible function for the given asymptotes. Now, if you have been given the graph, again, you can do the easy method. Put some random x values in the, say for example, you will have this equation in your answers, right? You'll have 4 different answers. You can start putting x values, say instead of this equation, instead of x, put 1 and check which is giving the correct answer in the graph. This is one way to check it. But if they want you to write just from these asymptotes, only if this is the question, it's very simple. I'll tell you how we do it. Now you need to know whenever the x is equal to 1, x is equal to 2, over here you can see these x values, isn't it? That means it's undefined over there. That is the vertical asymptotes, vertical lines. And this y denotes horizontal asymptotes, horizontal lines. It's very simple. If it is 0, I will start first. If y is 0, then all you need to do is the numerator over here must be having lesser power. See, the power over here must be less than the denominator. If you have over here power 1 and 2, that's enough. Then it is y is equal to 0. But when y is any other number, I'll come to that in a minute. But first, let me do x values. Can you see this? X is equal to minus 1, 1, 1, 2. That means in the denominator, just write the opposite sign of this. If we have x equals 1, x minus 1, and then x equals 2 means x minus 2 in the denominator. Why? Because now this particular equation is undefined at these 2 points. Because if x is equal to 1, what happens? 1 minus 1, 0, it's undefined. Now x is 2, 2 minus 2, 0, undefined. So whatever the values you have over here, just write them in the denominator in terms of minus. Now if you're thinking this one, no, that's fine. I'll write one more equation. Only the denominator I'm writing. X minus 1, x plus 1. Now if you multiply this over, if you multiply by distributive property or use a square minus b square formula, you are going to get x squared plus x minus x plus minus 1. Sorry. And then you can simplify this and it becomes x square minus 1. That's why it's written as x square minus 1. You can write what I just now wrote. You can just write x minus 1, x plus 1. This is a possible solution. There are many different types of solutions possible. I hope that is clear. And since over here we have 2x, it is x square in the denominator. Write the x over here lesser than the denominator's degree. So I can write x as power 1. That's why this is a possible answer. Now over here when y is not 0, all you need to do is write these denominators as it is. X, it will be minus 1, x plus minus 2. Here just write the same degree. It must be same. If there is here x and x, there's 2 degrees, right? Here just write same degree. And then the coefficient will be whatever this you have over here. That's the number. If it was 4, you just write 4 and the same degree of x. Now let's look at this one. Say for example this one over here. Minus 1 minus, see x is minus 1 and x is minus 3. Here y is 2. Write 2 and the same degree. Now what about this problem over here? Now this one, we can write minus 1 plus 1. It's very simple. Now why is there a square root? Why? Because now if you just have say x divided by x minus 1, x plus 1. This is a rational function, isn't it? What happens is you will have graph something like this, but you will have the same asymptote. Both the horizontal asymptote will be same, just one asymptote. See, in these cases, you will just have a horizontal asymptote at the same spot for both. But when we have two horizontal asymptotes, we need to split it out. So that's why when we put square root, basically, you will get like this one, two different points. Since you're not graphing it accurately, you will just be given these asymptotes. You will have same values. It'll be plus and minus 2 or 1. So all you need to do is write it as it is. X minus 1, x plus 1, and then you have over here what? 2. Just write 2x, but don't forget the square root. Now imagine this was 3 and this was 3, then all you need to do is this as 3 and then the square root for the given x vertical asymptotes. The question 8 is problems on related rates specific to electric current. Here, this is the question. You will always be given the equation. See, this equation will be given. What you need to do over here is derive it. See, this is the charge in the circuit. The derivation of charge gives you the electric current. That is what we have to solve for all the problems over here. Just derive q dash of t with respect to time. Now you need to know the product rule, the chain rule over here. So this is 10 is the constant. What is the derivation of e to the power anything? It's the same thing. But then the chain rule applies here. The chain rule is minus 5 because minus 5t would be minus 5. Then plus, here we have to do the product rule, u dash v plus uv dash. So here we have 2. Let's write that out, the constant. Derive the first term. It will be 1 times e to the power minus 2t plus, I'll leave t as it is now and derive e to the power minus 2t times chain rule will be minus 2. Then we have 3, sign will be positive cos 2t into 2. This is from chain rule because sine 2t is cos 2t times the chain rule will be 2. And lastly, I'll write it over here minus 7. Again, minus sine 2t times 2. This is the answer. We need to simplify this. It'll be negative 50 e to the power minus 5 times t plus multiply 2 times 1 is 2 e to the power minus 2t. Now this becomes minus, it'll be 2 times minus 2 is minus 4 t into e to the power minus 2t plus 6 over here, not 3. 6 cos 2t and minus and minus will become plus 14 sine 2t. Why 14? Because 2 times 7. So this is basically the answer over here. That's it. That's the derivation. You need to derive it. It's a bit lengthy. Exponential derivations are there. So that's the answer you can see. Yeah, that's the correct answer what we did. Since this is question number 8, that is in the MCQ part, you will have 4 options. If you forget derivation, you can do the calculator method for derivation. So I will do that as well over here. The calculator method involves pressing shift and the symbol over here, that's dy by dx, and then type this entire equation. 10 e to the power minus 5. There is no t, we write it in terms of x as the variable. 2x e to the power minus 2x plus 3 times sine. You don't need to put multiplication after 3. It's understood when you write 3 sine, they both are multiplied. Minus 7 cos 2x. And now take a random x value. Not very, very random. Take a suitable x value like 1, 2 or 1.5. I generally take decimals because calculator computes it for you. It's easier and you'll get a unique answer. Try avoiding certain values which will give this answer 0 or undefined. So here when I derive this at 1.5, let's see what's the answer. It's negative 4.19. Now I need to put all the 4 options in the calculator, and instead of this x, I need to calculate it at 1.5 because that is the value I have chosen over here. I have typed the entire equation over here in this calculator. I forgot to tell you one thing in the previous step. We have to use radian mode. My calculator was already in radian mode, so it was fine. I got the correct answer. You need to put the radian mode whenever you have sine and cosine, okay? Or any trigonometric functions. Now then, I will calculate this. Don't press equal to. If you press equal to, this is wrong. I've got negative 4.19. So calculate it at 1.5 and yes, negative 4.19. That's the correct answer. So this is how we can get the correct answer. But I realized that it's such a lengthy method over here for these, because the equations are too big. The derivation is fine. If you know the derivation well, just do it. But if at all you completely forgot the derivation, then you can opt for this calculator method. Okay. Now same thing over here. This equation is easy, so you can press shift dy by dx, put this entirely, and derive it at certain x value, and check your answers. Okay, you will have four answers. Check them at the x value of that, and it should match. Whichever matches is your correct answer. Or you can use the product rule over here and solve it up. But over here, a suggestion, you can simplify it by multiplying this inside. It would be, it is product rule itself, but it'll be, one term. It'll be much easier. I personally do that. I just multiply it inside, simplify as much as I can, and then derive it. Even over here, you can derive it entirely as product rule. These two, it is fine. And we have over here similar thing. The charge is given, you need to find the electric current. So basically you have to just derive this equation. Same thing. And even over here, just derive this equation, you'll get the answer. Now if the equation is too long, just try to derive it. Multiply this inside and derive it, or whichever method is convenient for you. That's how we solve this topic, just basic derivation. Now we move to the integral questions in the part 1 of the exam scheme. We have to find the antiderivative of a given function. We must remember the rules for antiderivatives. If you cannot remember them, or if you're not thorough with antiderivative, please watch the entire lesson explanation on antiderivative. You can find the link in the description. Now I'll use the power rule over here. Integral power rule means the x power increases by 1 and you divide by that. It is just the inverse or the opposite things of derivatives. So it will be 3x power 5 by 5 minus negative sign remains. Here it's x power 1, it becomes 2 by 2. And then we need to add a constant of integration c. This is very important. So this is the correct answer. Same thing over here, it will be 4 by 4 minus, what if there is no term? In derivatives, we dissolve this, make it 0. But here, we have to add an x because we're doing opposite. Because the derivative x would be 1, right? Now for 1, that means it's just a constant. The integral will be x. So we write minus x plus c. That's how we solve this. But if you have square root, it's the same concept, only that it will be x to the power half. And over here, we will take this to the above, it will be minus 4. And now use the power rule, it will be 3x half plus 1 will be 1.5 or 3 by 2 divided by 3 by 2. Now what happens over here is this will remain in the denominator, this will go up. So it basically becomes 2x power 3 by 2. That's the thing. And here what do we have? It will be x minus 4 plus 1 will be minus 3 divided by minus 3. So when you simplify this, you will have 2x 3 by 2 plus x 3 minus 3 by 3. Or you can write this as 2, this is square root. Anytime when you have divided by any number, that will be that particular radical. Over here, since it's 2, we don't write. It's understood, it's a square root. And over here, x cube plus, what happens here is you can take this down, it will be 3x cubed. So this would be the answer. So same concept is used over here as well. But here when you take this half up, it will be negative half. So these are the answers. Okay, now you can see they have not simplified so much. But this is also correct. It's not wrong. They have stopped over here itself. The only reason I did this is this might also be your option. You never know. If this is not there and they have given you this, please do try this one out by yourselves and then check for the answers. Here you don't have a quotient rule in integral, but you need to simplify them. Divide x half, this is denominator, so minus 2 by 3 And here you just take it to the above. It'll be basically there's no term, so it's 0 minus 2 by 3. So it'll be minus 2 by 3. Or when you bring it up, the power changes to negative. Then you need to use the power rule. What about sine and cosine? Always remember here, when you integrate sine 2, it'll be minus cos x. And over here we have plus sine x plus c. Same way you can solve that by yourselves. These are the answers. Remember, over here you need to simplify and then solve it up in these fractions, rational functions. Now, these are already simplified. You can't simplify anything, okay? If you remember the formulas of integrals, then you will know this is secant x. 2 remains, 2 secant x. This over here is sine inverse. So arc sine means sine inverse. 4 remains, it's a constant plus c. Sine inverse or arc sine. Now remember in your option, if there is arc cos, that means it's cos inverse. Now this is tan because we know derivative of tan is secant squared. So over here it's the inverse of it. Over here, we need to first simplify this. Let's simplify cos by sine. That will be cot. And over here, we have 1 by sine. So this is basically cotangent into cosecant x and 4 dx. What is the integral of cotangent and cosecant? We remember cosecant into cotangent is cosecant, right? It's CSC plus C, and don't forget the constant, it's 4 cosecant plus C. You can see that's the answer. Now I forgot to write it's minus. Whenever you have C over here, it's minus. Okay, this is minus. How to remember that? Whenever your answers are C, it will always have a negative sign in the answer. So it's good that I made that mistake. You guys, please don't do that in the exam. And please do try these by yourselves, individually solve them up. And here are the answers. These are pretty simple. Here, these functions are interesting because there's a rule in integrals. If the denominator and the numerator are related to each other, in the sense, if I have this derivative on the top, now if I derive x squared, what happens? I'll get 2x, right? Now here I can rearrange this and write it in terms of 2x. So what I do is, instead of writing 4, I can write 4 into 2x divided by x squared plus 4. And I know if I derive x squared plus 4, I'm going to get 2x. This constant, keep it outside, 2 leave it. This much part becomes ln magnitude of whatever is in the denominator, x squared plus 4. This is the rule of integral. So whenever you see the denominator and compare the above, and if you can relate them, then you can easily use this. So over here as well, what is the derivative of sine? It's cos. So just write ln sine x. Now don't think over here also it's about ln. No, there's no x over here. It should have been at least x. The number can be rearranged, that's fine. But there's no x term in the top. But when you look at this, there is 4x squared plus 4. You can remember tan inverse. So you can see, remove the coefficient and then you can do this as tan inverse. Okay, this will be tan inverse. Now this 4 is removed out and this is constant 3, right? 3 and 4 is removed. You will have 1 by x squared plus 1, that is tan inverse x. And over here we have got same answer. So these are the answers. Yeah, I've written it correctly. Don't forget to write the plus c. Same way do solve the others. Even over here, this is natural logarithm magnitude of e power x plus 3. Please try these by yourselves. Now I will show you the calculator method. Now before doing the calculator method, you need to know these all are related to differentiation, isn't it? Because if I say x to the power 2, if I differentiate it d by dx, the answer is 2x. Now here what happens is this is given as the question. Integral of 2x will be x squared. Why? Because x power 2 by 2 and 2 cancels. This is the answer. So they are inverse of each other and they are related to each other, right? Now when we derive this particular equation, we must get this, isn't it? If we derive it, we must get the answer with the question basically. So what we can do is, we can derive all the options and match it with the question. So it must be true. I will come and do this problem in a minute. Let me take a simpler problem which we had at the beginning. It'll be easy to understand and then we'll move to a difficult problem. Now imagine these are the 4 options and I'll take this question over here. First step, to make it easy, instead of starting to derive all the four options, let's take the question here. X cube minus 2. Sorry, you need to bring it down. Minus 2. Now assume an x value. Calculate this at any particular x value. I will take 1.5. It's already saved. So the answer is 11 by 8. Now, better to write it over here. At x is equal to 1.5, the answer was only the function, not the integral, 11 by 8. This is the answer. And now what you need to do is you need to start deriving all these four options at x is equal to 1.5 and match with 11 by 8. Now, if you're thinking, oh, we have this integral symbol, why don't we use that? But we need definite integral. It's specific limit. It's a definite integral. We don't have any definite integral values over here, so we cannot use this. So we have to do the other way around. Assume a x value to the given question, only the question over here, not the integral. Find the answer. Now derive all the four, that is by shift and dy by dx. I will start with this option. You need to type it out over here entirely, 3 by 5. I've typed it out over here. Now what about the constant value? I can write any digit or I can leave it. Why? Because when I derive any constant, say the c is 8, what happens with the derivative? It's 0, right? So this doesn't make a difference. I'll keep this 8 for now and I'll take the x value 1.5. Now this doesn't match over here, so this is not the correct option. But once again, let me just remove this. Plus 8, I'll just remove it out. And it's the same answer, but it doesn't match this particular question. But over here, that constant doesn't make any difference at all. So now change this out. Let the x value be the same. Only over here, you need to change it out to this particular question. So over here, we have minus 2x and the power is 4. And we have 1 by 4, 1/4. Now when we make this equal to, is it matching? Yes, it's 11 by 8. Only one of your option will match. There is no other value that will match, because if two values matches, then that means there are two answers. That cannot be, it'll be only one specific answer. Imagine you get directly at the beginning itself, it's fine, but otherwise you need to do until the answer matches. So you will definitely get one answer, but you need to do it properly. If you have trigonometric functions, please make sure you put this into radian mode and then do it. That's the only thing over here. And let's do another last problems over here which look difficult. This one I'll just do it over here. You will have to first write this value as it is. Press on, or you can just clear your calculator. Now use the fraction symbol, type it out. Now, once you have typed it out, choose a x value. I'll calculate at 1.5 and I've got this 1.6693. So here we need to know all the four options. Now we have the options over here. All you need to do is shift dy by dx. I'll put the correct answer itself directly. Alpha x minus 3e is over here. Shift and ln. Minus alpha x. Don't put any constant. You can put, doesn't make any difference. I'll put the x value 1.5 and we're getting the same answer. You can try with others, it won't match. Now if it's ln, it's over here. Don't worry about this magnitude symbol. If you want the magnitude symbol, I'll show you where it is. Shift and HYP, you'll get the magnitude symbol. But generally over here it's an x, so don't worry about it. Just avoid taking any x value that makes it negative. That's it. Take a 1.5, it's fine. That's how we solve this integral antiderivative part. Now please try to remember the formulas and solve it by using the formulas itself. But somehow you just can't remember the formula, you just are frozen, in the exam. Then try to use the calculator method. It's good to know different methods. Only when the options are given, the calculator method can be used. In this video, we will learn about indefinite integrals. Indefinite integrals basically means there's no interval. There is no specified interval of integration. Like the limits are not given. Say it's 0 to 3. This is definite integral. Indefinite must be any limit. Now here they have specified some values. This is to find the constant term. We have to just do integrals by the formulas and solve it up. Now, if you remember, before we have done the similar problem in differentiation, we had been given the position function with respect to time, and we were asked to find acceleration or velocity. If we derive position function, d by dx, we would get what? We would get velocity, and if we had derived velocity d by dx with respect to time, we would get acceleration, all are with respect to time. This was the thing. Now we go the opposite side. Integrals is opposite, right? When we integrate this, we must get only velocity. Over here we have, and when we integrate velocity, we must get position. That's the concept. So here they have given us the velocity function. All you need to do is integrate the velocity function and find the position s of t. That is equal to 3 minus 2 t integral dt, because they have given in terms of time t. If you want, you can just change this to x and dx, that's fine. Now what happens over here? Use the formulas, power rule, there's nothing, it'll be 3 times t and minus 12t square by 2 plus c. This is important, but we need to find the position function, and they have given the initial position already, so we can find the constant of integration. What we need to do now is we need to apply this over here, s of 0, right? Now we have this term as s of t, so substitute as 0. So what happens? Everywhere wherever t is there, make it 0. 12 into 0 square by 2 plus c. What happens here is now don't write s of 0, because we know what is s of 0 value, it's 3. Write that. Here it will be 0 minus 0 plus c, so 3 is equal to c. So the position function with respect to time would be 3t minus 12 by 12 will be 6, 12 by 2 will be 6t squared plus 3. This is the answer. Now, if you're thinking, oh, is it always the c value? This will always be the c value. No. If it is sine function and any polynomial, yes, it will be always this. This will be directly taken as c. Here, is there any sine function or exponentials? No, right? So we can directly take it. Otherwise, if there is cosine function or if there is exponential, you need to substitute and do this, because this changes. That's how we do it. We'll see one more problem. Now, remember in the previous video, that is the question number 9, we had done a shortcut method for integration in calculator. Yes, that is absolutely possible in this, because there's only one integral to do. You can take this and check over here. That's possible. But the problem is, if you have, say, two options, this is one option, and one more option is like this itself, but they have given like, say, minus 6t squared plus 0. Now this is a problem. We know this, for this particular case, this is the correct answer. It should be plus 3 as c. C is 3. But what if your option is something like this? Then we can't use the calculator method, because for both we'll get the same answer. So try to remember the formulas over here and try to solve it by yourselves. You can see the answers are worked out over here. Now, what about this problem? It's the same thing. But do you remember the formula for e to the power minus t? E to the power minus x, the integral is e to the power minus x, but minus sign is there. So we will have to remember that. So integral of 3e minus t minus 2 dt. It will directly be minus 3e to the power minus t minus 2t plus c. And over here you need to substitute this 0 everywhere. Now this is basically s of t, right? Now s of 0 will be minus 3e to the power minus 0. 0 is neutral, doesn't matter the sign. 2 times, this is 2 times 0 plus c. Now here, what is s of 0? It's 0. Then we have minus 3 here. Okay, because this is 1. E to the power 0 is 1. Minus 0 plus c. So c will be equal to, take this to the other side, positive 3. So this function over here, minus 3 e to the power minus t minus 2t plus 3. This would be the final answer. So that's how we solve this one. You can see the answer is negative 3 e to the power minus t minus 2t plus 3. It's not 0. Don't directly take it. And here now we have been given the acceleration function, not the velocity. So we have to integrate it once, find the velocity, and then integrate it again. But both the times when you do it, you have different constant of integration. So we have to substitute by step. We will solve this now. So velocity with respect to time would be integral of 3 sine t plus 1 dt. Now what will be the integral over here? It will be 3. Now the answer is cosine t. Whenever you get the answer of integral as c values, in the sense cosine, cotangent, cosecant, you have to put a minus sign. Plus 1 means you have to write t. That's it. Plus c. Now how do you find the c? So we know the initial velocity v of 0 is over here 0. So let's substitute everywhere t values as 0. So cos of 0 plus 0 plus c. Now what is cos of 0? If you put in the calculator, you'll get 1. So minus 3 times 1 plus 0 is gone, plus c will be equal to v of 0 is 0. So 3 will be equal to c. So this is the constant of integral for the velocity function. So velocity with respect to time t will be minus 3 cos t plus 3. This is the answer. Now this is not a final answer. They have asked for the position function. Integrate this over here. So integrate both the sides, you will get position function. So integral of 3 cosine t plus 3. Here it will be minus 3. What is the integral of cosine? It is just sine. The sign is positive itself. But we already have a minus sign, so we leave this as minus, plus t squared by 2 plus 3t plus c. Here we need to find the constant of integration for the position function. So let's substitute s of 0 because we know the s of 0 value, right? So everywhere, wherever t is there, put 0 plus 0 squared by 2 plus 3 of 0 plus c. C will remain as it is. Now what is s of 0? That is 4, the initial position, minus 3. Okay, everything becomes 0 over here. Why? Because it's sine. 0 plus 0 plus 0 plus c. So c value is 4. Now substitute back in the position function. S of t is equal to minus 3 sine t plus t squared by 2 plus 3t plus 4. This is the final answer. This is the position function. And that's how we solve it. Here the entire solutions are worked out as well. You can I just realized that this is wrong. They have missed out, see, this constant part 1, right? They have just forgotten over here. So they have not written t. So that's why this answer is wrong. All the other things are correct, but they have forgotten this t initially. So that's the reason. Please make a note. Please follow what I've written on the screen now. This solution for the 47th question is wrong. I apologize for that. Now, other questions are straightforward. I'll just go through the solutions. Here they have to, if you have to integrate it, yes, it becomes like this, plus, yeah, it's all right. And then you need to find the initial, use the initial position and find the c value, and then substitute, and then integrate this. Everything is all right over here. This is the answer. So that is how we can solve the position functions from velocity or from acceleration. If you have any doubts, please post them in the comments. In this video, we will learn how to use sigma notation to compute summations. Here the questions will be like this. You have the summation symbol, that is also called as sigma. And what this means is you need to multiply 3i squared, where I is being squared. I can vary from 1, 2, 3 until the maximum limit of 6. So it starts at 1, ends at 6. You don't need to go to use any formulas. We can directly solve these by using calculator. I will show you now. All you need to do is press shift and this over here log base symbol, and you will get the summation. But here you don't have I, instead of I it's x, variable x. That's fine. Wherever you see this below term, it can be even changed. Over here it might be m. If this is m and there will be m over here, you need to substitute that as alpha x in your calculator, because your calculator only takes x values. And the square over there, and you start at, press the next, and you start at 1 and end it at by pressing up 6. That is your answer, 273. You can compute by summing it, or by formulas you'll get the same answer. Same thing over here. All you need to do is change these limits. It ends at 7 but it starts at 3, and over here we have I squared, that is alpha x squared plus x, alpha x, and that is your answer, 160. Similarly, please do try them all by yourselves and you can check the answers over here. Even if you use the formulas, you will get the same answers. Now, these are pretty simple. All these work. Let's just try this one as well because it's a huge number. It is 8 minus x. It starts from 1 and goes up until 50. It might take some time, and the answer is minus 875. So that's it. Sometimes it might take about 30 seconds, 12 seconds, it varies because I remember my students in the class were counting the time and telling me as well. All these over here, there is n, right, instead of I, but in your calculator, it will be x itself. Very straightforward problems. All these are same, but we will go to one more type of problems over here. It starts k is equal to 3 and ends at n, which is not known. And over here, it's k squared minus 3. So let's write it out. Shift and log base symbol, you get this summation. Alpha x squared. Why I put x instead of k? Because k is the limit over here. X squared minus 3. It starts at k equals 3 and ends at n, which I do not know, but I'll just assume a number. Don't assume a big number. Don't take 100 or something. I will just take over here, say 20. You can take 10, doesn't matter. Okay. And the answer over here is 2811. Now look into all the four options. This is question number 11. You'll have four options and this is the final answer. You will have four different answers having the variable n. Now remember this answer, 211. Type this out as it is. I'll just type instead of n, I'll put it as x, alpha x plus 1, close the bracket. And again, open the bracket. It is 2 alpha x plus 1. Close the bracket and go down over here. It's 6. And we subtract 3 times alpha x plus 1. Sorry, that is not correct. Alpha x plus 1. Now calculate it at the n value which I used. I had used 20 and this answer must match. It is 2811. Only one option will match with your question. All the other options will give you something other than 2811. Only this particular correct option will give you the correct answer. So this is how, even if there is n, you can easily solve it up. You can try this by yourselves. Just take any n value, substitute any n value. You can substitute say 10 and find the answer, write it down. Then look into all the four options and substitute over here instead of n as the n value you are chosen. You have chosen 10, substitute everywhere 10 and compare. Only one option will give you the correct answer, so that will be your answer. So this is how easily you can solve these summation problems in calculator. In this video, we will learn how to estimate the area under the curve. The questions will be given something like this with a table of values. We have to use left endpoint and right endpoint evaluation. This is very easy method. You should just understand when we use the left endpoint, we have to use the leftmost value. See, from this f of x values, from this we begin. We start this, next this, and it goes on. We don't use the last value. This is omitted. We leave that. Only these are added and multiplied by the interval. Because left endpoint means we start with these only and the rightmost value is not used. So that's the thing. So what do we do is, the formula is very simple. F of x, that is summation of f of x into delta x. Now what is this delta x? It is the interval. Look at the interval, the jump. It is 0.1, isn't it, between each? So there are how many intervals? If n is given, n values are given, n minus 1 intervals. So that's why we leave one value. But in the left hand point, we leave the rightmost value because we start counting from left side. Whereas in the right endpoint method, we start from the right side and we omit the last left value. That is the only thing you need to know in this topic. It's such an easy one. All you're doing is, look over here, adding up all these for the left hand endpoint method. You're adding up from the left side. See, f of 0.0. You can directly do it. Add this. 2 plus 2.4 plus 2.6 and until 1.4. And then you multiply all of this with the interval that is 0.1. That is the formula. And the same thing over here with the right endpoint, you can start with 2.4 because you're leaving the first value, the leftmost value. You can either do 0.6 plus 1.42, or you can start from the second value and add up the whole and multiply it with 0.1. You're multiplying 0.1. Same method is followed for all the other problems. One of the easiest topic over here. Please go through this. Try to use your calculator and solve this by yourselves. Remember, add these all values for the left endpoint from the left side, leave the last one, and multiply by the interval. Here the interval is again 0.1. For the right endpoint, start from the right side, leave the leftmost point, and multiply by the interval 0.1. And please do this. Over here the interval is, the jump is 0.2, so we multiply by 0.2. That's it. Very easy topic. Use your calculator, solve a couple of problems, and you'll be very thorough with this. In this video, we will explore the properties of definite integrals. Here we have a very straightforward problem of definite integrals. We have been told the integral 0 to 4 f of x dx. But we have the function f of x as a piecewise function, where x less than 1 is one certain function and greater than or equal to 1 is given by something else. So here there's a problem. We can't take the interval 0 to 1 directly for f of x. We need to split this up. How do we split it up? It's not 0 to 4, sorry. How you can do it is 0 to 1 is one particular function, and then because it's less than 1, so you can take 0 to 1 as 2x dx plus, then from 1 to 4 we will consider the next function because this is valid for anything greater than or equal to 1. So 1 to 4 is 4 dx. Now we can just use the calculator. In the writing part, we have done the written method for this using formulas, but now we will just use the calculator and solve it up. All you have to do is integral, the definite integral symbol as you can see here, press that up. And now let's type 2 alpha x, and the limit starts from 0 to 1. And then press next. Over here, press plus. And again, definite integral, write the function, it's 4 from 1 to 4. And that's the answer, 13. The final answer would be 13. For this question, it's the same thing, but first we need to change the limits here and then the function as well. So I'll write it out over here. What is the limit? The limit breaks from 0 to 2. And from 0 to 2, we will take 2 dx plus integral from 2 to 4, we will take 3x dx. Now you can just put this in the calculator and get the answer. Please do try it by yourselves, and over here the answer will be 12. Now let's try these problems. Here they are asking you to write these integrals, definite integrals, in a single term, single interval. Now there's a rule, whenever you have 0 to 2 and this starts from 2 to 3, this is common over here, right? Then you must look at the functions. The functions are also same. We can write it as 0 to 3 directly, f of x dx. How you understand is, now you start from your home. Say you went to the gas station and then to your school. Your initial position was over here, your home. You stopped over here and finally you reached home. Now if I'm just telling where did you go, you went from your home to the school. So I can directly even tell you reached over there. This is just to understand, it's not practically applicable over here. This example is okay, not that great, but it makes sense over here in the next problem. Let's do that over there. But before that, I hope you understand if there is two terms over here, that's it, done. And provided it must be a plus sign. If it's minus, it's not possible. Now here we have 0 to 3. Fine, but we have minus. But look over here, are these two numbers matching? No. But here there is 3, so we will swap them up. We will write minus, but when we swap this 3 down over here to 2, we have to multiply minus. It'll become 2, and over here 3 f of x dx. Now what happens? Integral 3 to 0, over here it becomes plus. So this is f of x dx. And there'll be plus integral 3 to 2 f of x dx. Now we can see this is a common number, so we can just write 0 to 2 f of x dx. This is the answer, and it's plus in the middle. Now that example over here, 0. Now let's take 2 and over here 3. You wanted to go to 0 to 2, but you went over here to a position 3 and then you reached over here, but ultimately your goal was to reach 2. You have reached over there anyways, so this is just a detour. That's fine, you can remove it off. Okay, I just hope you understand that's the rule. You should just apply the rules and simplify them. It'll be 0 to 2 f of x over here, 0 to 3 f of x for the first one. Same way, please do try these by yourselves. Over here, they are straightforward because both are 2. It'll just be 0 to 1. In this case, it'll be minus 1 to 3. And then you have to just write f of x dx. So these are the answers over here. And what about these? Over here, they have given us the values of f of x and g of x. And then we have to solve them up. This is again a simple topic. I'll do the B. The question B is integral 1 to 3. All the limits are matching. Otherwise, if it doesn't match, you cannot use it. You must see which matches and use the appropriate one. 2 times integral 1, 3, 2 times f of x. Now, what is this? I will remove that integral because we know the value for integral f of x is 3. So basically, this limit is multiplied inside for both the terms, okay? But you can directly do this. 2 times f of x is 3 minus of minus 2. That's it. Now this dx is removed. Why? Because we are applying the value for the integrals. So we directly substitute the values. Over here it's 6 plus 2. The answer is 8. Same thing over here. We have to just do 3 minus 2. The answer is 1. And it is as easy as it can get. This is 1. This is 8. Similarly, please do try these by yourselves and then watch the video. Over here we have 4. G of x is minus 2 minus 3 times f of x is 3. You can just put in the calculator and solve. Over here we have f of x minus of minus 2. It will be plus, so it will be 5 over here. Minus 8 minus 9. It will be 16, 17, minus 17. So these are the answers for these problems. Very simple problems. And that's the end of this topic. Another very easy topic. Please use your calculators. Try to do it as directly as possible because the options will be given to you in this problem. In this video, we will solve problems on integral mean value theorem. You will have problems like this. All you need to remember is the average value function theorem because they have asked you to compute the average value of the given interval. That's given by this 1 by b minus a integral f of x dx. The limits are from a to b. Now the limits over here given, the initial one is a, b. Same thing over here, a and b. And this is the function. So all you need to do is substitute over here. B is 4 minus a is 0. Integral a is 0 to 4. Function is 2x plus 1 dx. You just put this in the calculator, you get the answer. Same thing over here. You can see that integral x squared plus 2x dx. The interval starts from 0 to 1 and the limit is from 1 minus 0. Just multiply this, you will get the answer. Let's do it in the calculator now. All you do is substitute it as it is. 1 divided by 4 minus 0 will be 4. You can put a multiplication, or even if you don't, you will get the correct answer itself. It's better to put the multiplication sign. It's 2x plus 1 from 0 to 4. That is the answer. The answer is 5 here. And just use this formula and direct method. You can see this is the substitution. This is the formula substitution. You can use other methods, but this is the easiest of all. Now, what about the next one? Same thing, just change it up over here. The limits are from 0 to 1 only. And here we have 2x, that is the 2x plus x squared. I've just written it other way around. It's x squared plus 2x, but you can write it whichever term first. That's fine. You'll get the answer. And don't forget what is being multiplied. This is not 1 by 4. It is 1 by 1 minus 0. That's 1 by 1. The answer is 4 by 3. So this is how you can easily solve these problems up. Please do these two by yourselves. and then check for the answers. And what about this one over here? Now, in these exercises, we have to find the C value that satisfies the conclusion of the integral mean value theorem. So let's write the formula of integral mean value theorem. It is b minus a to b, f of x dx, right? Now this thing we will consider it to be f of c, this entire thing. Now let's substitute based on this formula. It is 1 by what is b minus a? It will be 2 minus 0, integral 0 to 2. F of x is 3x squared dx. This is function of c. Let's take c as just a random term. Now, because we'll find this value in a minute. Now here it will be half. And what is this part? Integral of 0 to 2, 3x squared dx is given equal to 8, right? So this becomes 8 equals f of c. So what is f of c? Cancel this, it will be 4 is equal to f of c. Now we got the function of c equals 4. So now a c value that satisfies the integral mean value theorem would be f of c. That means instead of x, just put c over here. That's the thing. Now what we know, f of c is 4. This must be satisfied. So take the 3 to the other side. It will be 4 by 3. That is equal to c squared. It is square root plus or minus 4 by 3 is equal to c. This is the value that satisfies the integral mean value theorem. So the answer is, over here you can split the square root. It will be, what happens over here is it will be plus or minus 2 by square root 3. Because you can, 4, square root 4 is 2, right? So that will be the final answer. Okay, now I forgot about an important thing. I wrote plus or minus. But can I have negative sign over here? The limit is from 0 to 2. So it's only positive. Okay, why? Because though that's the answer, C value, we have to take only the positive value because that falls inside the limit interval. Sorry. And now the same thing can be done over here. All you need to do is write up the formula. It is 1 by, I'll directly substitute the values. 1 by b is 1 minus of minus 1, and integral minus 1 to 1 x squared minus 2x is equal to f of c. And now I will solve this up. It will be minus of minus 2, so it will be half. And what is this value? It is 2/3. That will be equal to f of c. So what is f of c? It will be 1 by 3 is equal to function of c, f of c. And now here we have f of c will be equal to, from this given equation, c squared minus 2c. And now we know this is 1/3, that is equal to c squared minus 2c. Let's take this 1/3 to the other side. It will be 0 equals c squared minus 2c minus 1/3. Now how do you solve this? In the formula mod phi 3. All quadratic equations can be easily solved by mod equation, that is phi, and 3 is for quadratics. And now substitute the coefficients of c squared is 1, then we have minus 2, and lastly the constant term is 1 divided by 3, sorry, minus 1 divided by 3. And now the answer is this and this. Now which falls in this limit? Let's just press this ST. This is 2.15. This is no, not the correct answer. It's this second term. So it's only one answer that will fall in the limit. That's from minus 0.15 is within this limit. So that should be the answer. Here they have told plus or minus, but sadly no, this it's only minus. Okay, see the first one is plus, which is 2.15, which is beyond this interval, sorry, not limit, interval. And I just misuse both the words. And over here we have, this is the answer. That should be the answer, but sorry for the, I apologize for the mistake here. So that's how we do these problems. That's a very simple one as well. If you have any doubts, please post them in the comments. We move on to the last question of the exam scheme. This is about the fundamental theorem of calculus. The problems are very straightforward. All of this can be easily solved in calculator. I'll show you one of them. All you need to use the definite integral symbol in your calculator and then type the equation 2 alpha x minus 3. It starts from 0 and goes until to the intervals over here mentioned, and that is the answer. Please do try all of these problems by yourselves, but I will go to one of the tricky problems. Before going to a tricky problem, this one over here, exponential. Now let's do it. The same method, integral. To get the exponential, you need to press shift and natural logarithm symbol. The power is minus 3 alpha x and then plus 4. And the limits, intervals, sorry, are over here. The thing is, you get 5.9004. But the option may not be the same. Option may not be decimals. Look over here. The answer is not at all in decimal. So how would you check which is your correct answer? So what you need to do is write this answer down somewhere. It's 5.9004. And then solve all the four options which you have. Now I'll solve this one out. It's minus 2 by e to the power 3 plus 6. So when I press SD over here, or when I just press equal to over here, I'm getting the same answer when I solve this. So this is the correct option. So only one option matches with the answer. All the others will be wrong. So that is how you do it. Even over here, the same method, you will get in decimal form. You need to simplify all the options and then check which is the correct answer. Now coming to this trigonometric function. Remember, if your calculator is not in the radian mode, by pressing shift, mode and 4, you won't be able to solve these. So please get them in the radian mode, and now you can type it out as it is. This one is simple and straightforward. If you type it properly, you will get the answer, no problem, but I'll do this one. Now here, you don't have cosecant, cotangent. Let's write 3 into, what do you write? We write reciprocal. What is cosecant equal to? It's 1 by sine. So I write, use the fraction symbol, 1 divided by sine alpha x over here and close the bracket. Multiplied with cotangent, that is reciprocal of tan, 1 by tan and alpha x, close the bracket. And what are the limits? It's pi by 4. Use the fraction symbol first, shift and pi, divided by 4, and you go up over here. It's again pi divided by 2. Now, when you press equal to, you're getting an error. The problem is we are using reciprocal identities. If at all these identities become 0 or undefined, you won't get the answer because we don't have an option to directly put cosecant or cotangent or secant values. So what you can do is, a simple trick to avoid everything is just multiply these by 0.999. Now I know why this has become undefined because of pi by 2. If I multiply just 0.99 to pi by 2, it's enough. But still, to be on the safer side, I'll just multiply many 0.99s to these intervals. Why? Because now they are very, very close to these numbers, but not exactly this number. It's not pi by 2, but it's very, very close to pi by 2. Now if I press equal to, I'm getting a proper answer. You won't get this exactly in your answers. You need to solve all the options. So it's 1.2426. Here, let's simplify all the options. That's 3 minus 3 plus 3 root 2. And the answer we get matches what we got. See, more than 4 decimal places match. So that is the correct answer. So always remember, in order to avoid any math error with the reciprocal identities, just multiply the intervals by 0.999. Same thing over here. I'll do this one. I've typed this given equation as it is, but the secant is not defined in the calculator. So I've written 1 by cosine x square. Squared outside. If it's cos square x, that means we square outside. You can even put the bracket over here, but even if you don't put, it's fine. It's understood. And 0 to pi by 4. I know cosine function is defined at pi by 4, so I'll just press equal to, the answer is 1. And over here, the answer is 1. So that's how we solve these type of problems. Whenever the intervals are given in numbers, it's very simple. Just put them in the calculator, you will get the answers. Even over here, it's very straightforward. Instead of x, we have t, but still the answers are just numbers. Here you need to solve all of the 4 options and match with your answer. For these type of problems, what you do is, first simplify if you can. Sine square x plus cos square x is 1. This is the Pythagorean identity. Just simplify it. And now we have 0 to 1. First, let's integrate and then apply the limit. Integration of 1 is basically x. That's it. Now you need to apply the upper limit, t, minus the lower limit. The answer is t. If you're thinking what happened to c, for the definite integrals, we don't, because it'll cancel off anyways if we put c as well. We have done the same thing in the written part, so please watch that video over there. Detailed explanation is given. Over here, I'm just doing it quickly. This will cancel off. The square and by 2 cancels off. You have just e to the power x. So now what is the integral of e to the power x dx? It's just e to the power x. Apply the limits. It'll be e to the power t minus e to the power 0. And what is e to the power 0? It's 1. So this is your answer. So this is the way to substitute and solve. It's e to the power minus 1, and over here it's just t. That is the end of all the part 1 questions. I hope you have found all my videos helpful. If you have found them beneficial, please do share it with your friends and please do subscribe to my channel. That would mean so much to me. And I would highly encourage all of you to solve more and more problems by yourselves. And if you have any doubts, any queries, please do post them in the comments and I'll try to get back to you very, very soon. I wish you all the best for your exams. Happy learning to all of you.